Hello there, CP Algebra 1B, and welcome to Unit 11 Review, Part 2. Okay, this one is going to involve dividing radical numbers and also solving them. So remember some steps when dividing. First, you're going to want to try to divide. So try to divide for number 1 here. That's just to see if anything simplifies. So 9 divided by 16 is, as a fraction, it does not simplify. So really, all you should recognize is, hey, if it doesn't simplify, square root of 9 by itself is 3, and square root of 16 by itself is 4. So that's all it is. If you notice those square roots right off the bat, that's all you need to do. Remember, there shouldn't be any radicals in the denominator. We'll worry about that for the next one. 20 over 45. So here's one where you try and divide. 20 divided by 45. This time we come out with 4/9. So before we square rooted anything, it's square root of 4/9. Then we can take the square root. So square root of 4 over square root of 9, and that just becomes 2/9. Okay, so try and divide. That breaks it down, and then square root. For number 3, so 5 and 3, they're not going to simplify any. But we don't want that radical in the denominator. That's a problem. So remember, we need to rationalize. Rationalize. And we do that by multiplying by the square root of 3 over the square root of 3. What that does is, so we have 2 roots of 5 times the square root of 3. The 2 doesn't multiply anything fancy, but then the radicals of 3 become the radical of 15. Okay, the denominator, for the time being, 3 times 3 is the radical of 9. The nice thing that happens is that square root of 9 is really 3. So it's 2 roots of 15 all over 3. That's your final answer, okay? Remember, you cannot divide the square root of 15 divided by 3 because that's a radical and that one is not, okay? So that is your final answer. Rationalize by multiplying the same denominators. Number 4, similar. This time we're going to multiply top and bottom by square root of 5. So 2 roots of 15 all over the root of 25. And then the root of 25 just becomes a regular 5. And very similar to the last question, again, 15 and 5 can't reduce, as tempting as it is. That's a square root, so it is not divisible by 5. Solve each equation. Remember to check for extraneous solutions. Main idea with these is get the radical by itself. So square root of a, we are going to first divide by -3. -9 divided by -3 is +3. That's equal to the square root of a. Then you can square both sides. So isolate and then square both sides. So we have a is equal to, because the square root and the square cancel, is equal to 9. You can use your calculator to double check these. 3 times the square root of 9, -3, and we should get -9, and it does check out. So that one checks out. Number 6, so the radicals by itself, this time we just have an operation inside, so we're going to square both sides. So 25 is equal to x plus 3, subtract the 3, that's 22 is equal to x. You can certainly take that and double check it. Square root of 22 plus 3, well, that's the square root of 25, which certainly is 5. So it checks out. Alrighty, so hopefully you're doing pretty well so far. 7, don't let the fraction scare you. This time, just radicals both sides. So square both sides, that makes it just x over 2 is equal to 6 minus x. I would multiply each side by 2. All right, and that's going to get rid of our fraction. So on the left, we just have x is equal to, now you just want to be careful to distribute, 12 minus 2x, and then you can solve by adding 2x, sorry. Getting ahead of myself here, which makes it 3x is equal to 12 divided by 3, and x equals 4. Good idea to check. 4 over 2 is 2. Square root of 2 is equal to 6 minus 4, 2. Square root of 2, they check out. 8, similar. Square both sides. So 5x is equal to 4x plus 1. I'm going to subtract 1. Going to subtract 4x. And 1x equals 1. Hey, that's pretty simple. Divide everything by 1. X equals 1. You don't even need to include that step. Good idea to check. So 4 times 1 plus 1 is the square root. So square root of 5, is that equal to square root of 5 times 1? Certainly it is. So it checks out. Last two ones here involve the most bit of work. So we're going to square the left, square the right. 12 minus v is equal to v squared. If there's a v squared, you need to set equal to 0. Okay, and again, I recommend keeping the v squared positive. So I'm going to subtract 12 and add the v. So 0 is equal to v squared plus v minus 12. Key way that you rewrite it so it's in standard form. Then we need to factor. Remember how to factor. So v, and it would be plus 4 and minus 3. 4 and negative 3 gets you 12, negative 12. And then you split each and solve. So v is equal to negative 4, and v is equal to 3. With these ones, the only real solutions you're going to have are going to be the positive options for the questions I'm going to give you at least. It's still a good idea to check because when you plug in the negative, so that one is extraneous. When you plug in the negative, the only option is that you do, so 12 minus negative 4, is that equal to negative 4? Well, that's 16 square root, and positive 4 is not equal to negative 4. So the negatives are typically always extraneous. Not always, just typically always. In future courses, it may not be the case. Number 10, similar, square both sides. Did you hear my kitty? He's being a pain in the bum today. N squared, he hears me giving all this attention to you guys and not to him. Well, I will get him in a moment here. Squaring both sides. Again, set equal to 0. So I'm going to add 15. It's okay, bud. So n squared minus 8n plus 15. Factor. Factor is 15, add to negative 8. Both negatives, so that would be a negative 5 and a negative 3. And then n equals 5 and n equals 3. They both work in this case. Again, you can check that out by just trying them. So negative 15 plus 40 be the square root of 25, which would be 5. And same idea, negative 15 plus 24 would be the square root of 9, which is 3. Okay, so both of those work. Remember, check for extraneous, practice those problems, and expect similar stuff coming up. Great job, guys.